Our Earth is covered by over 70% water, but only about 1% of this water is safe for human consumption. This leaves about 17% of the Earth's population without any access to clean water. To many of the people in Southeast Asia, this is an often deadly problem. The water is more abundant in Southeast Asia than in certain areas like Africa. The water is far more likely to be contaminated for a variety of reasons. Quite often in cities, the water comes in contact with sewage and industrial pollution that is never properly removed. This is due to outdated cleaning facilities and lax dumping standards. In addition to this, many of the means used to store the water are crude and often lead to more water contamination. In recent years, there have been big population and industrial booms in these countries, which attributes to a lot of the pollution in the cities.
On the other hand, in the more rural areas of Southeast Asia, less of the pollution in the water is due to man-made causes, but instead because of the existing poor water conditions. The climate is moist and hot, which makes any of the stagnant bodies of water a breeding ground for disease and bacteria. If used properly, this climate may be used as an advantage for the people of Southeast Asia. With the proper design and materials, a solar oven could be a great way to harness the elements that often contribute to their poor water quality and instead direct them into a source for clean water. Sunlight, a plentiful resource in the area, can be used to heat and eventually boil the water. Once boiled, this water will be far safer than most of the water that is often used in these lower income areas. Although solar purification is used in some cases, our hope is to make a system both cleans the water and is simple to use. Though Southeast Asia has many of the same problems as third world countries, the industrial presence in these countries means that citizens have more disposable income than one would typically expect.
Keeping these factors in mind, our design included an umbrella with a reflective surface lining the underside. When placed upside down and on the ground, the parabolic structure of the umbrella can use the reflective surface to direct the sunlight at a container placed at the focal point. This sunlight will be used to eventually boil the water in the container, cleaning it in one of the safest and simplest manners possible. With a design this specific, we would hope to market a product that streamlines this process so many families could purchase a finished version ready to be used. In addition to this possibility, others in the area can try to replicate this design in an attempt to be more cost efficient. Our ultimate goal is to provide as many people with clean water through our version of the solar oven,